Welcome back. I'm really glad that you stuck with me so far in this tutorial series, and I know you are excited to actually get down to some serious network configuration. So let's not waste any time and let's get right to it. Before we get started, I would just like to pause for a moment and highlight what we will be covering in today's tutorial. To get us started, we will look at default attributes. And basically, a default attribute is one that you would set, and after setting it, every object that you create that uses that attribute would have that default value configured. Next, we will look at command line variables, which is a really nice way for us to pass the value of attributes through the command line. Next, we will look at constructors and helper classes, and we will see how we could pass attributes using those. And then we'll move on to namespace-based access. And while we do this, you will see how we can use something called the configuration path that will help us to locate objects within our simulation. And finally, we will then look at pointer-based access. Let's now look at our network diagram from our tutorial on building simple network topologies. You would remember that we simply created this topology in NS3 and we compiled it and ensured that it was actually running properly. Now we're actually going to go ahead and actually configure some of the attributes for the objects that were created. And you will notice in this diagram that we have all of our nodes fully labeled. For instance, we have workstation 1 and all the routers and the file server, workstation 2, printer 2 as well. We can see the subnets that we created in that tutorial. And we can also see some labeling for the actual values of the attributes that we want to set. So for instance, we have the data rate, the propagation delay, and so forth that we want to set for different parts of our network. We can see here that we also want to set some default attributes. For instance, we would like that every net device that we create would have a value of 10 megabits per second associated with the speed of that device, and also every channel to have a value of 2 milliseconds for its propagation delay. You will notice though that, for instance, on subnet number 2, that we would like the data rate for the net devices to be 50 megabits per second and the delay for that channel to be 4 milliseconds. And we can also see over here on subnet number 5 that we wish the data rate of these point-to-point net devices to be 100 megabits per second. And of course over here on subnet number 4 we have a different delay as well for the propagation delay, and that is quite different from the default value of 2 milliseconds. So with this plan in mind, we are going to start our live programming session, and we're going to start off first of all configuring the default values, and as we work our way through the simulation we will configure the other values for the different subnets as we go along. So let's get started with our live programming session. So I have my CentOS 6.2 virtual machine up and running, and I'm going to enter into the NS3 folder, and I'm going to navigate down to the ns3.14.1 folder, and I'm just going to right click in the open area here and open up a terminal, and then I'm going to go into the scratch folder and I'm going to double click on tutorial.cc, and this is basically the file that we would have completed at the end of the building simple network topologies tutorial. So if you have that file and you have NS3 up and running, you could follow along with me as I go through this tutorial session. So what I want to do first is actually show you how to create a command line variable and then pass that variable via the command line. So I'm going to go over here to the internet and I'm going to look at the NS3 Doxygen. So we are pulling up the online documentation for NS3. I'm going to type command line, and we are looking here at the command line class reference And the command line is used to pass command line arguments into a simulation. So we have here a couple of constructors as well as some functions to add a value as well as to pass values via the command line. So the add value function here, this first one on top, we can see that it takes three parameters. The first one being a string which represents the name of the command line variable. Then we have a help string that gives us a description about what the command line variable is. And then we have a value that we pass as a command line variable. So what I'm going to do now is go back to our code and let us begin. So I'm going to create a little comment here. So this section starts off our command line variables. So I'm going to create a variable. It's going to be a string. I'm going to call it speed. And I'm going to put a value of 10 megabits per second into that variable. And then I'm going to create a command line object. I'm going to call it CMD. And then I'm going to add a value using the add value function. And the first parameter is the name of the command line argument. In this case, it's going to be default. I'm going to call it default rate. And I'm going to give a little help string here that tells us something about that command line variable. And I'm going to say this is the default data rate to be used on network devices. And then I'm going to also now provide the actual variable to store the command line variable when I pass it into the simulation. That variable is speed. And then I'm going to pass those command line variables using the pass function. And I would need to take these two variables here that we normally use when we pass variables into the command line and in a regular C++ file. So once we pass them in, they're going to be available within our simulation for our use. So before I complete this little section, I just want to display what the value of the speed is. So we're gonna just create a little message here. Speed equal to speed ENDO. Alright, and that's going to display what the speed is for us, actually whatever is inside of this variable. And I'm now going to compile it. Let's see if everything is okay. Okay, so let's run it now. Run Scratch, it's in the Scratch folder. It is tutorial 6. And there you can see that the value of the speed is 10 megabits per second. It's the same value that we entered initially here. And you notice that I did not specify any command line variables, and therefore it would use the value that's in speed once we have never actually specified a command line variable. Once we go ahead and specify a variable, let's see what happens. So our variable is default rate, and we're going to pass 100 megabits per second. Let's see what happens. Excellent. You can now see that the speed is 100 megabits per second instead of 10 megabits per second. That is because we passed a value of 100 megabits per second via the command line using the command line variable that we created. And now that value of the speed is available within our simulation, for use during configuration. Now that I've shown you how to create command line variables, I'm now going to show you how we can set up some default variables. So going back to our diagram here, we can see that we wish to set the data rate to 10 megabits per second for all net devices, as well as the propagation delay to 2 milliseconds for all channels. So we're going to set up some default attributes at this point in time. But before that, I want to actually look at some documentation before we get started. And I'm going to actually go into the NFC source code. So I'm going to double click on the source folder, and we need to set the data rate as well as a value of the time for the delay. So the data rate object, I believe, is in the network module, and it's in the utils folder. So I am looking for data rate. I'm going to go to datarate.h, and if I scroll down here, let's see, for the constructors, we have 3 constructors. We have a default one here, then we have one that takes a value of the data rate in terms of a 64-bit integer, and then we have one that takes the data rate in terms of a string value. So what I'm going to do is create a data rate object using this one here. Alright, so let's go back to the code. Where's my code? Yeah, there's my code. So let's go just a bit below here. Let's create a simple comment. What should we put it as? Let's say configuring default, let's see, attributes. Let's create a data rate object. We know we need a string value in this case, and remember we created a value here called speed, and it indeed is a string. So let's copy that, and we will put that right there. And now we want to also go ahead and create a value that will store the time, which will represent the propagation delay. So let us go back to the documentation. So I'm going back into the source folder, and I'm going to look into the core module because I'm looking for the nstime.h file, which allows us to, well, it defines what a time object is. And if I scroll down a little bit, we can see we have several different ways of actually creating time objects. I'm interested in this one here, where we can actually create a time object based on a string value, and you can see the several options that you have. You could define it as seconds, milliseconds, microseconds, and so forth. And I also want to show you another way you could actually create a time object. If you go up here a little bit, you can see that I can create a time object by passing another time object, and we can get this time object here from some special methods at the bottom of this file. Let's see if I can find them. So let's see. Okay, for instance, right here we see that if I call the function called seconds and I pass a double variable defining how much seconds I want, it returns me a time object, which I can then use in the creation of a time object using the constructor that I just showed you. And you see we can do for milliseconds, and we can also do for microseconds, and so forth. So let's get back to our code. Let's see if we could create a time object. So I'm going to create a time object here, call it delay, and I'm going to pass a string, and that string is going to be 2 milliseconds, because if you recall, That is what we want to set as the default propagation delay for all channels. So we set it as 2 milliseconds. If I wanted to use the other method, I could have said something like time delay, and I could have passed here milliseconds, and we could have passed a value here of 2, and it would be equivalent to the same thing. So just a few ways we could do certain things in NS3. There are multiple ways sometimes to achieve the same goal, but I'm going to stick with my original choice, and that is a simple way we could create our data rate value, our data rate object, and our time object in NS3. So what we're going to do now is we're actually going to look at how we could actually configure the default values for the net devices as well as for the channels that we created in our simulation. So to be able to set a default value, we need to actually make use of the set default function, and we can find that if we go back to the source folder, we're going to the core module this time, and I believe it's in here. We are looking for the config.cc. Well, actually, let's look at the config.h. I think it should be defined in here. So we have here the set default method or function. We can see that it takes a string, which is the name of the attribute that we want to set, and this would be the actual value that we want to set it to. So let's go ahead and see how we can do that. So first I would like to actually, let's go back to the code. I would like to set first of all the default data rate on the point-to-point net devices. So I'm going to call config. That's the method is set default. Okay, that's not default. That is still not default. Wow, I do need a pair of glasses. Okay, that is default. So it's set default, and we want to actually make use of some more documentation. Let's go back a bit, and let's the internet actually. So let's actually look here for the point-to-point net device, and by now you should be familiar with using either the Doxygen or the NS3 source code to find what you need. So let's look at the class reference. I'm scrolling down to the list of attributes. So I want to set the data rate. So you can see here it's set with a data rate value, and the underlying type is a data rate object. So what I'm going to do now is go back to the code, and I'm going to actually need to select that particular attribute. So it's done this way. So we create a string, and we actually reference the class itself. So it's going to be point to point net device, and we also now specify the actual attribute, which in this case is the data rate, and now we need to specify that data rate value. And remember, it took a data rate object, and we have one available to us, which is what we created. And I can see here that this actually has an error, so let's fix it. We would have known that if we actually had compiled it, but let's fix it one time. So we're going to call that variable rate, and let's actually pass it here. Alright, so what that actually did is actually create for us, we actually set a default value or default attribute called data rate, and we pass the value, which is the rate, which we would have set up as 10 megabits per second. So from this point on, whenever we create a point-to-point net device, it's going to use this default value for the actual speed of the net device. So let us go ahead and compile this, because we haven't actually compiled in a while. So we will not know if we actually made any errors. So let's just double check. Okay, so that's fine. So let's go back to the code. So we've set the data rate. We also wanted to set the actual propagation delay on the channel. So we'll use config again, set default. Okay, that's looking a little short. Let's set default. And let's go and look at the point-to-point channel. Let's scroll down to, okay, oops, a little bit hasty there, was I? So let's scroll down, and we can see we have just, well, we have an attribute called delay, which is what we're interested in. So we can see that it's set with a time value, and the underlying type is time. It's a time object. So that should not surprise you, because you can see that I created a data rate object as well as a time object. So now let's go ahead and set that up. So it's going to be, the string is going to be ns3 double colon. It's going to be point to point channel, and we're going to specify it's going to be delay, and then we know we're going to use a time value, and then we pass a time object, which in this case is delay. Alright, so let's compile that. And there you have it. Okay, so let us do the same thing for CSMA net device as well as a CSMA channel. So I'm going to use config again. Config, set default. I'm going to specify here ns3 CSMA channel, and the attribute is data rate. And then it's set with a data rate value. Data rate value, and we're going to pass a data rate object, which is rate. Let us go ahead now and do it for the channel. Config, set default, ns3 c. Okay, that's not right. Sorry, this is CSMA net device. Nobody told me, did you? That's not nice. So it's CSMA net device. This one is going to be the CSMA channel, and it's going to be delay for the attribute. We are going to set it using a time value, and we're going to pass the same variable called delay. Okay, that's not delay. Okay, so I'll just save that and let me see if I made any mistakes. Okay, so we're okay so far. So what we have done so far is actually we have actually created some default attributes. So we have created a data rate object and initialize it with the speed value that we had up here, or it could be whatever we pass via the command line as well. And then we had a time object which represented the propagation delay, and we use the config set default function to actually set the data rate and delay attributes on the point-to-point net device, point-to-point channel, as well as the CSMA net device and the CSMA channel. So let us continue with our configuration. So I'm going to go back to our network diagram here, and what I want to do at this time is to configure subnet 5 to use a data rate of 100 megabits per second on all of the net devices that will be configured within that subnet. So what do we do next? Well, let's look at some more documentation. Let's go back to the Doxygen, and let me pull up for a second the CSMA helper, because we are going to be using the CSMA helper to actually configure. Configure here, configure device attribute, and we're going to pass here a string that represents the name of the attribute, and of course the attribute itself, the value of the attribute. So let's go ahead and do that. So we are going to make a little bit of space here, and actually that's not what we're going to do, I believe. All right, there it is. Let's put it where it should be, because we have the CSMA helper object here, and I'm going to create a little comment here. We're going to say we're going to configure the data rate for subnet number 5. Okay, so I'm going to use the CSMA helper object that we created and call the set device attribute. Let me just make sure that's correct. Yes, it is set device attribute, and I'm going to choose the data rate attribute. Okay, that's not correct. Data rate, and then I'm going to set it using set a string value and pass a value of 100 megabits per second. Okay, yeah, that looks correct. And I'm going to save that, and now we are going to actually compile it and make sure that we are okay. Alright, so we have just completed configuring attributes via actual helper. So let's move on now and continue with the rest of our configuration. At this point in time, I would like us to shift our attention to subnet number 2, and what we want to do here is to actually configure the point-to-point devices with a data rate of 50 megabits per second, and the channel, this point-to-point channel, with a propagation delay of 4 milliseconds. So first, to do that, we have to have a way of actually locating these devices as well as the channel within our entire simulation. And what is going to help us do that is something called a configuration path. And if you recall from our previous tutorials, we would have spoken about something called the node list as well as the device list. And I'm also going to introduce in a little while something called a channel list. And by using those entities, we'll be able to actually construct a configuration path, which would allow us to actually access these particular objects within our simulation. So let us take a look at what a configuration path looks like. So I'm going to go over here to the online documentation where I have the class reference point-to-point net device already displayed. So let's look at where we have the attributes defined. So I'm scrolling down to that section, and you can see here that we have something called a configuration path. It says here that a point-to-point device is accessible through the following paths with the config set and config connect functions. And we can see here what a configuration path looks like for this particular object. So you can see that we have the node list, which we should be familiar with by now. You are also introduced to the device list, and it also has here the actual object that we are dealing with. In this case, it's a point-to-point net device. And we can see here that we have the attributes listed for us to be able to reference. So let us go ahead and see what this actually looks like. So I have here the actual configuration path that we're going to be using when we're going to configure these point-to-point net devices. So I have here, for instance, this is the configuration path to the point-to-point net device on router 1. So you would remember that in that particular node list for our simulation, that the host machine called workstation 1 would be at node 0. Then we have router 1, router 2, router 3, router 4. We have the file server. I think we have workstation number 2, and then we have the printer. So node 1 actually is router 1. So we have it at index 1 in the node list, and then we actually now continue to locate where the point-to-point net device is, and it's at index of 2, because if you look at the diagram, we can see here that on router 1 that this point-to-point net device would be at index of 2, because it would have been the second point-to-point net device created on this node. We actually created subnet 1 first, which placed this point-to-point net device at an index of 1, and then we actually created subnet number 2, which placed the second point-to-point net device at an index of 2. So if I go back to our diagram here, we can see again that router 1 is at index 1 in the node list, and that point-to-point net device is at index 2 in the device list, and then we specify that we are actually looking at a point-to-point net device, and finally we actually specify what the actual attribute is. So you can see a clear path through our simulation all the way down to the actual attribute that we want to configure. Similarly, for router number 2, we know that router number 2 is node 2 in our node list. So you can see we have 2 appearing here, and the point-to-point net device in question, which is this guy here, he was the first one that was installed on router 2. So it is actually at an index of 1 in the device list. Again, we are specifying a point-to-point net device, and we are looking at the data rate attribute. So to actually do our configuration, we will use the set function from the config class. And again, you can see here that the first parameter is a string, which is the path. So it's the path to the location of the object in simulation. And the second parameter is the attribute value, which is the value of the attribute for the object. And you can see we have some attributes here that I took from the actual documentation. Before I actually get back to configuring the net devices in NS3, I just want to introduce one more concept, and that of it's called a channel list actually. And you will notice in our network diagram we have 5 channels: 1, 2, 3, 4, and 5. And you notice I've labeled the point-to-point channel between router 1 and router 2 as channel 1, and the point-to-point channel between router 2 and router 4 as channel 3. Well, similar to your node list, where you would have actually had all the nodes um, being stored within the node list, it's the same for a channel list. So the channel list actually keeps track of all the channels you would have created, and of course, obviously they are done in terms of the order in which they were created. So we know we created here, we created subnet 1, subnet 2, subnet 3, subnet 4, and subnet 5. So therefore, subnet 1, the point-to-point channel here, would be channel list 0. This one would be channel list 1. This one would be channel list 2, and this would be channel list 3, and then channel list 4. So it's no surprise that I've labeled this channel 1 and channel 3. So with that, we will be able to actually get access to this point-to-point channel and configure a delay of 4 milliseconds. So looking at our diagram here, we can see again that the channel between routers 1 and 2 would be channel 1, and we can see the channel list. It is at an index of 1, and we simply specify that it's a point-to-point channel that we are looking at, and we specify the attribute, which is the delay. So with that, we are now able to fully be able to configure both our point-to-point net devices and our point-to-point channel on subnet number 2. So let's go back to our NS3 code and get back to our configuration. So I'm going to scroll down and look for where I started subnet number 2, and that's here. And I'm going to create some variables. So I'm going to start off by using a comment. So we're going to say that we are configuring attributes specific to subnet number 2. And then we are going to create a data rate object. I'm going to call this rate underscore subnet 2, and this one will be 50 megabits per second. 50 megabits per second. And now I want to create a time object. I will call this one delay underscore subnet 2. And I'll create this one a little differently from what we did before. I'll use milliseconds. And we want 4 milliseconds for the delay on that point-to-point channel. So I'll save that, and then let us go ahead and actually use the config set method. So I scroll down just about here. After we would have assigned the IP addresses to the nodes in subnet number 2. So I'm going to use the config set, and I'm going to create a configuration path. So we're going to use node list, and for router number 1 it's a node list 1, and and the device would be a device list, and that will be device list 2, and we are specifying here a pointer device, and then we actually specify the actual attribute, which is data rate. Mhm. And the next parameter would actually be a data rate value, and we're going to pass there, we're going to pass rate underscore subnet 2. Alright, so that was for router 1, and we're going to do the same thing for router number 2. So I'm going to copy this line, and we know that the node is at an index of 2 and the device list is at an index of 1, and everything else would basically be the same because it's the same value that we're actually setting. And then I would like to go ahead now and do one for the channel config set. So it would be channel list. That's not right. That's better. Channel list, and it would be an index of 1, and we are specifying here a point-to-point channel, point-to-point channel, and the attribute is delay, and we're going to set it with a time value. And what we're going to pass here is delay underscore subnet 2. And that simply completes the configuration for subnet number 2. So you can see that we used a configuration part to access the attribute, or the object actually, and then we actually set the attribute on that particular object, and it's as simple as that. So let's go ahead and save this. Alright, and let's compile it and see if we did everything okay. Okay, and there you have it. The last piece of configuration that we have to do would be to configure the data rate to 100 megabits per second on the point-to-point devices in subnet number 4. Then we have to configure the propagation delay to 5 milliseconds for channel number 3. So we will be doing this via pointer-based access, and if you remember from our previous tutorial, when we're using pointer-based access, we actually have to dig through several layers to actually get to the object that we are interested in. So if you look at this diagram I have here, we can see that if we want to manipulate the data rate attribute, we are going to have to get access to the node, and then on the node we're going to have to get the particular point-to-point device, and then we're going to have to actually configure the particular attribute using the set attribute function. Going back to our configuration file, we could actually now begin to configure those attributes on subnet number 4. So let's look and see where subnet number 4 is. Subnet number 2, this is subnet number 4, so this is what we want. So I'm going to go just below where we created the devices, because I actually want to get both of those net devices, the one on router number 2 and the one that's on router number 4. So I'm going to create a comment here. So we're going to configure the net devices configure the net devices. Let me just change that. And this is on subnet 4. So let's go ahead and get the net devices on each of those nodes. So I'm going to create a smart pointer to a net device. Wow. Smart pointer to a net device. I'm going to call this one device A. And we're going to use the device container. So we're going to use subnet 4 devices. Remember, the device container actually holds the devices, net devices. And I'm going to get the first device, which is at an index of 0, and that is going to be the device that is on router number 2. And then I'm also going to do the same thing for router number 4. I'm going to get that device that's sitting on that node. They call this device B. So it's going to be subnet 4 devices dot get, and it's going to be index of 1. So the get method here returns first a smart pointer to a net device, and that is what we store in these variables. Alright, so this one is for router number 2 and this is for router number 4. So now we want to actually convert these to regular pointers. So I'm going to create a pointer to a net device. I'm going to call this device A underscore PTR. Okay, that's not an underscore. And I'm going to call peak pointer, which will return a regular pointer given the actual smart pointer. And I'm going to do the exact same thing for the other one. So creating a pointer to a device. This is device B underscore PTR, and I'm going to call peak pointer again and pass here device B. So let us save that at this point, and let's just compile it to see if we are okay. Okay, so we have some errors. So you can see here on line 129 it says net device was not declared, and that is because we obviously did not spell it correct. Let's see 129. So let's fix that. What else did we have? Okay, well this is as a result of the error saying that we did not use a particular variable. So let us go ahead and compile it again. Alright, so that is actually quite fine, because what happened is that we have created these two variables here and we have not actually gone ahead and used them. So let's go ahead and do just that. I'm going to use these two values to actually get a pointer to a point-to-point device, because the get method here actually returns a pointer to that device, and what is actually stored on the nodes itself really is a point-to-point device, because that's what we actually installed. So the point-to-point device is actually a subclass of a net device. So you're going to have to do a bit of downcasting here to get access to that actual object. So I'm going to create here a point to point and the device. It's actually a pointer I'm creating, device, and I'm going to call this P2P device A. So I'm going to do a dynamic cast, and I'm going to specify that I'm casting the object in question down to a point-to-point, as well a pointer to a point-to-point net device, and the object I'm casting is a pointer to a net device, and actually it's this variable here. See if I can get it. Alright, so that will take the pointer to a net device, which is device A, and actually it's device A underscore PTR, silly me, and it will take that and downcast it to pointer to point-to-point net device. So I want to do the same thing for the other one. So I'm going to change this to B, and I'm going to change this to B, and that will give us a pointer to a point-to-point net device in each case. So with that said and done, now I want to actually create a data rate variable that we're going to use in our configuration. So I'm going to call this rate underscore subnet 4, as we did similarly before, and the value we're going to use in this case would be 100 megabits per second. Okay, and then we could go ahead now and actually proceed to set the attribute, because we now have access to the actual point-to-point net device. So I'm going to call the set attribute function, set attribute, and we need to specify the attribute name. In this case it's going to be data rate, and we're going to set it using a data rate value, and the value we're going to use is rate underscore subnet 4, and I'm going to do the same thing obviously for the other one. So this is setting the attribute for the point-to-point net device on router number 4. Alright, so it will be P2P device B, and we'll set the attribute, and it's the same value of 100 megabits per second, and that now gives us 100 megabits per second on both of those devices within subnet number 4. So I'm now going to configure the point-to-point channel on subnet number 4. So let's see, I'm going to start off first by creating a comment. So we are going to configure, and we configure the channel on subnet 4. So I'm going to create a smart pointer, and it's a smart pointer to a channel. I'm going to call it channel, which is quite original, and I'm going to have to actually get the channel that is on subnet number 4. So to do that, I'm just going to hop over to the online documentation, and I'm going to look at the channel list. So you can see here that we have a function called getChannel that takes the index of the channel within the channel list, and it gives you back a smart pointer to that particular channel object. So let's go ahead and use that function. So I'm going to call that static function, in channel list. It's get channel. That's what it was. Channel is two ends. So get channel, and the index of that channel is an index of 3 in the channel list. And once we do that, we will have access to that particular channel. Now I will go ahead and convert it to a regular channel, a regular pointer to a channel. I'm going to call this channel underscore PTR. So I'm going to use the peak pointer function again, and that will help us to convert the smart pointer to a regular pointer. Alright, and now we'll have to go ahead and actually we'll create a variable. We'll create a time object, create time. We'll call it delay underscore subnet 4, and we're going to set a value there of 5 milliseconds. Alright, let's just save that and compile it, see if we are okay. Alright, so that's fine. We have an unused variable, and that's okay because we have not used the channel underscore PTR variable as yet. So let us go ahead and use it. So we will first, well, I'll first go ahead and do a downcast because I need to cast that channel pointer down to pointer to point to point channel. So let's quickly do that. Point to point channel, and we're creating a pointer, and we will call this P2P channel. Okay, and we're going to do a dynamic cast. Okay, so we're going to cast channel underscore PTR, and we cast it to pointer to a point to point channel. Okay, and then with that done, we can actually go ahead and configure the channel. So it's going to be P2P channel. We're going to call the set attribute function. So the attribute is delay, and we are setting it with a time value, and we actually going to pass this time object in there to complete the configuration. And let's just compile and see how we're going. Okay, so our configuration is complete. So we have configured on subnet number 4, we have configured the point-to-point devices all the way down to configuring the channel, and you can see how much more work that was, especially when you compare it to using the actual configuration parts. And this is what 3 lines of code compared to plenty lines of code. So the preferred method really is to actually use the config part, and that is what I typically use when I do my network configurations. So I will now conclude this tutorial by looking at what we actually did. We started out looking at command line variables, where I showed you how to create a command line object and add command line variable state, and eventually pass a variable into the simulation via the command line. I then showed you how to set up default attributes so that if you have to create multiple objects with the same value, you just set up a default attribute, and every object from that point in time will have that default value. We then looked at configuring via the helper classes. So we configured Subnet 5 using the CSMB helper. And then we looked at namespace-based access, where I actually introduced you really to the config part, and you saw how we were able to use the node list and the device list. And I also introduced you to another list, which is the channel list. And finally, we did some pointer-based access, and we made a little comparison between the namespace-based access and pointer-based access. And you can see that the namespace-based access is much more efficient. And from this point on, that is the method that we are going to use to access and manage our attributes in our simulation. So I hope this tutorial was beneficial to you, and I hope to see you again in our next tutorial.